Oh, good evening, ladies and gentlemen. It's good evening here in Los Angeles, California. Okay, I am now on lesson 8 on integral calculus. Lesson number 8 is still the evaluation of indefinite integrals under logarithms. Okay. For tonight, this will be the last examples before we will proceed with the integrals of exponential functions. The next topic will be exponential functions, the integral of exponential functions. We are finishing tonight the example problems for the evaluation of indefinite integrals for logarithms. Okay, let's proceed with the last 5 examples for tonight. I think this is just more than good enough examples for logarithms. Okay, let's proceed with problem number 1 tonight. We are given the integral of x cubed dx all over x squared plus 1. We are to evaluate the integral of that one. Okay. On the first look, it seems we could not think of an integral formula in which to integrate this one. But since the highest power of the exponent on the numerator is greater than the highest power of the exponent on the numerator, I think it's a good choice if we will divide the numerator by the denominator first before proceeding with the integration. Okay, let's try to divide x cubed by x squared plus 1. Longhand division. We will divide x cubed by x squared plus 1. The first term here will be x. Why x? Because if we multiply x by x squared, it will become x cubed, right? And if we subtract, it should become 0. So I think it's a good thing that the first term here, the answer for the resulting division will be x. X times x squared is x cubed. X times 1 is plus x. Okay? Open quantity, close quantity, we will subtract. Okay? The operation is subtraction to eliminate the first one. So x cubed minus x cubed is 0. So this is now 0. Okay? No x here, so 0 minus x is just minus x. This is minus x. And this is the remainder. Okay? Meaning, the value x cubed divided by this will be equal to open quantity x. That's the first answer we got, right? Minus the remainder. Minus x over x squared plus 1. Then try to integrate the terms. It's a sum or it's a difference. Okay? The first one will be the integral of x dx minus the integral of x dx all over x squared plus 1. I think if we now try to observe the resulting problem after the division, they are now both integrable. For the first one, we will let u is equal to x, du is equal to dx. Second one, u will be x squared plus 1, du will be 2x dx, 2x dx plus 0, okay? Because the differential of 1 is 0, so this is now 0. Or du will just be simply 2x dx. On the second one, we are lacking the constant 2, right? We miss 2. So we will just place 1/2 outside. And for the first one, I think this falls under the power formula. It falls, the integral of this is actually this is actually x to the first. X or just simply x to the first. It falls under the power formula. The integral of u to the n du. The second one, it falls under the integral of du over u. Right? And for the first one, this should be u raised to n plus 1 over n plus 1. So this will now be x raised to 1 plus 1 over 2, or just simply 1/2 of x squared. The second one, we insert 1/2 outside because there is a 2 here from the verification. The natural log of u, but what is u on the second one? It is x squared plus 1. This is plus c. Final answer, 1/2 of x squared minus 1/2 of the natural logarithm of the quantity x squared plus 1 closed quantity plus c. That's the final answer. Okay, that's problem number 1. Okay, let's proceed with problem number 2. Problem number 2, it falls under trigonometric, but this is under integration of trigonometric function. Okay, the integral, it's not trigonometric. It falls, the solution is under natural logarithm, but the given function is trigonometric. The integral of secant of x tangent of x dx all over secant of x plus 1. If this falls under the natural logarithm, the 1 on the denominator should be u, so I will let u is equal to secant of x plus 1. Take the differential of both sides. Du will be equal to the differential of secant. The differential of secant or derivative of secant is secant tangent times its differential. So it is secant of x tangent of x times dx plus 0. This is actually plus 0. The differential of 1 with respect to any variable is 0. So this is plus 0, or just simply du is secant of x tangent of x dx. It is exact. Why exact? If you try to look at the resulting differential, okay, it is same as this. So this now falls under the integral of du over u, and this is actually equal to the natural logarithm of that u plus c, or as a final answer, this will be the natural logarithm of u, but what is u? Secant of x plus 1 plus quantity plus c. That's the final answer. Simple. If you know your differential, there's no problem. Okay, that's the final answer for problem number 2. Okay, let's proceed with problem number 3. Problem number 3, the integral exponential, but the solution falls under the natural logarithm. E to the x plus e to the minus x all over e to the x minus e to the minus x times differential x. Okay, if this falls under the natural logarithm, the value of u should be the 1 on the denominator. So I will let u, or we will let u equal to e to the x minus e to the minus x. Take the differential of both sides. We should verify the value of du if it is correct. Du will be equal to e to the x, okay, times plus dx. Okay, I place plus because this is plus, right? Minus e to the minus x, and the differential of minus x is minus dx. It is minus because this is minus. So e to the x, this will now become plus e to the minus x, open quantity, close quantity, times dx. It is exact. Okay, same as this. Right? So the integral should become equal to the integral this given function, the integral of du over u. And after verification, du is exact. So the final answer will be natural logarithm of u plus c. But what is u? It is e to the x minus e to the minus x plus quantity plus c. That's the final answer. The solution of this is by using your knowledge of the differentiating exponential functions. Because without knowing it, you cannot bring out the solution. That's integral calculus. Okay, let's proceed with example number 4. Example number 4, it's under trigonometric. The given function is trigonometric, but the solution is under natural logarithm still. The integral of secant of theta, differential theta equal to. Okay, this will be equal to secant of theta, differential of theta. We will multiply the right hand side by the factor secant theta plus tangent of theta, secant of theta plus tangent of theta, because this is actually 1. Right? But we can do it. So if we try to multiply the given secant theta, differential theta by this quantity here, after the expansion, secant is secant square theta, secant tangent is secant theta, tangent theta, open quantity, close quantity, differential theta, all over secant theta plus tangent of theta. Okay? If this falls under natural logarithm, the value of u will be the one under the numerator. So we will let u equal to secant of theta plus tangent of theta, taking the differential of both sides. The differential of u is du. The differential of secant of theta is secant tangent times differential theta. That's differential calculus. The differential of secant is secant tangent. So this is secant theta, tangent theta, differential theta. And the differential or derivative of tangent is secant square of that angle. Secant square of theta, differential theta. Okay? We factor out differential theta. What will come out? What will come out? What will come out? It is secant square theta plus secant theta, tangent theta, open quantity, close quantity, differential theta. And this is exact. Right? It is exact. After the verification, du is exact to be the one on the numerator. So this now falls under the integral of du over u, and this should be equal to the natural logarithm of u plus c. But what is u? U is secant theta plus tangent of theta. So the final answer will be natural logarithm, open quantity, close quantity, secant theta plus tangent of theta plus c. That's the final answer. The topic is under integration that leads to logarithms. But the given functions are mixed. Some are algebraic, some are exponential, some are trigonometric, but the solution is under natural logarithm. Okay, let's bring out the last example for tonight. Number 5. The integral of differential theta all over sine of theta. Okay? 1 over sine of theta is cosecant. The reciprocal of sine is cosecant. So 1 over sine is actually cosecant. So we could rewrite the given problem as cosecant of 2 theta, differential theta. And if we try to follow the solution from number 4, we will multiply the given resulting equation by cosecant 2 theta minus cotangent of 2 theta all over cosecant of theta cotangent of theta, because this is actually 1. Right? But we can do it. So cosecant is cosecant square. Okay? Cosecant times cotangent is cosecant cotangent. Open quantity, close quantity, differential theta. All over cosecant of 2 theta minus cotangent of 2 theta. And if we think that the solution of this is under the integral of du over u, okay, we will let u equal to cosecant of 2 theta minus cotangent of theta, the one on the resulting denominator. Taking the differential of both sides, no problem. Well, we passed by differential calculus already. du will be equal to the differential of derivative of cosecant is cosecant cotangent. So negative cosecant of 2 theta, cotangent of 2 theta times the differential of the angle. The angle is twice theta. So this should be 2 times the differential theta. Okay? It is twice. Minus open bracket. The differential of cotangent is negative cosecant square. Negative cosecant square. I am just recalling the differential calculus, right? Negative cosecant square of 2 theta, and the differential of the angle is twice differential theta. So this will be minus minus, okay? We bring it in front, and there is a factor 2, so this is 2. Cosecant square of 2 theta, I put this one in front, okay? And the negative thing, I put it as a second term. Negative cosecant theta, cotangent theta. Negative cosecant of 2 theta, cotangent of 2 theta of close quantity differential theta. It is not exact. Why? Because there is a 2 here. So to counter this 2, we put 1/2 outside. So this will now be 1/2. And this will become under the integral of du over u, right? We put 1/2 because there is supposed to be 2 inside, right? So the final answer will be 1/2, the natural logarithm of u plus c. But what is u? Final answer will be 1/2, the natural logarithm of cosecant of 2 theta minus cotangent of 2 theta, close quantity plus c. That's the final answer. It seems easy if you know your differential calculus. Right? I think that's just more than good enough for tonight. If you like it, please click like. If you want to share it, click share. And if you want to subscribe to my channel, lesson number 8 for tonight, please click subscribe. Thank you.